So now I just want to walk through those same air delivery systems. And this time I'm going to focus on two items. One is the accumulation of moisture due to the drying front, because that is a pet peeve with all farmers, and most air delivery systems just have to deal with that fact. But there are some systems that are trying to eliminate that problem. And the other thing is basically the length of the airflow path. Different air delivery systems can modify how far the air has to travel to get out of the bin, and I'm just going to touch base and sort of discuss how those the different designs impact how far the air has to travel. The first one again is the full floor aeration. This one, obviously, the air has to travel 100% vertical, and the airflow path is fixed by how full you fill your bin. You don't have any control over that. The drying front is going to be horizontal, and it will accumulate moisture at the core. That's just like most air delivery systems. That's just one of the downsides of in-bin drying. So you will very likely have to move your grain in order to get rid of that core. The one scenario that gets around this core is the introduction of a stirring mechanism in a full floor aeration bin, and this is a really common and quite effective way of eliminating that core and actually enhancing the airflow by stirring the tough and the dry grain, and that is a common path for farmers to take is converting their full floor into a stirring bin. Now the simple grain tube or aeration tube, it again, if you look close at the airflow path, you've got, say, a quarter of your air is going out the top of the aeration tube, but it's going out radially in all directions. And if you look at the worst case scenario, or the air that is being pushed out the bottom of that aeration tube, you can see that air has to go down, turn around, and it has to come back up. And assuming this is 24 inches, you can see that air has to probably go close to 3 feet before it gets to the top of this grain tube. So you can see there's a percentage of the air here that is got a lot tougher path to take. And ultimately, when looking at air delivery systems, you want to find a system that provides an easy path for the air to get to all the grain and to get out of the bin by traveling through the least amount of having the least path. And you can see here that a quarter of the air here is traveling a very long path. So that's in part why the simple tube tends to be a little less effective than some of the premium systems. The other item is the drying front. Again, it has just a horizontal drying front. You do accumulate a core at the top of your bin, and moving is almost always required to prevent spoilage. The inverted trough is again, this is sort of an extreme case of what we just discussed, in that all the air is forced out the bottom. So we don't have the benefit of having some air going a nice short efficient path. It all is forced out the bottom. And not only does that introduce really high velocities in this area so that you have more friction, but it forces an additional 3-foot path for that air to get out of the bin. So that will add to the inefficiencies, and it just is something to be aware of when choosing which bins to do your in-bin drying in. Drying front is horizontal, and once again, you will accumulate moisture at the top of the bin, and you will have to move and blend your grain to prevent spoilage for winter storage. Here's the louvered inverted trough, and again, you can see that what they've done is they've added some louvers on top, so that introduces a path for air to exit the top of your air delivery system, and that adds significantly to the efficiency. So now potentially you can have half your air taking an easy path and only half having to travel the long tortuous path out of the bin. So you can see how this will impact your efficiency and will reduce back pressure. The drying front is unchanged. You will accumulate moisture at the top of your bin, and you will have to move and blend your grain for winter storage. Here's our first premium air delivery system, and it's the Cube. And as we have discussed, the Cube has very good louvered area. That there is some airflow is pushed downwards and in a less efficient path, but the lion's share of your air delivery is upwards or to the side. So this has should be a very efficient way to get air into the bin. I also like the fact that you are injecting a lot of air into the core, so that any of those fines that might be hindering your airflow, they're basically negated by having excessive air. The drying front with this system, and I want to also point out that these drying fronts that I'm putting on here, these are just my interpretation. There's nothing scientific about it, but I'm just trying to illustrate how I expect the moisture to migrate, and ultimately it migrates with the direction of airflow. Now with the Cube, I envision higher airflow in the middle of the bin, so I expect you would get less of a moisture buildup because you're going to have higher airflow here, and ultimately the sidewalls might have a little more moisture just because you don't have as much airflow on the bin walls. But again, this is just a qualitative analysis. The rocket is very similar to the Cube. Again, you've got very little airflow being injected into the bottom of the bin. Probably it's just enough to dry the bottom of the grain in the cone. The majority of this air is going outwards or upwards, and it also is up higher in the bin. So you have a nicely reduced path for this air to get out of the bin. Exactly the same as the Cube. You likely will get better drying in the core, so any fines will be a non-issue, and the drying front would likely look similar, where you would have the bin walls would probably be drying slower than the core because of the excellent airflow through the core. Here's an interesting, I guess, adaptation of the rocket, and basically what they do is they add sidewall vents. Here's an image of a sidewall vent, and it basically is attached to the sides of the bin. Typically there are 4 of them, and the way this works is that the purpose is to try and exploit the idea of horizontal airflow. Now, the only way that you can get significant horizontal airflow is if you give the air a path to exit the bin on the bin walls. So the way that this works is you start with step 1, and these sidewall vents are open. So you'll start up and you will be injecting, the lion's share of your air is injected in a very optimum, sideways direction. It is going to try and travel the easiest path, which is horizontal. And as it hits these sidewall vents, it's going to exit. So what this does is, and what you would see in a system like this is, even if your bin is full, you would see relatively low static pressures when you have your vents open, and you would be drying the bottom portion of the bin first, and your drying front would likely be a vertical drying front, and it would move from the center of the bin outwards. Now, with this, oops, I got ahead of myself. Now with this, you get really efficient air delivery because of the reduced airflow path and because of the horizontal flow, but you also get the benefit of moving the moisture out of the bin quick. So instead of bulldozing all that moisture upwards into your attic and creating a core, it's exiting right now, and that way you don't accumulate the core like you would in other systems. Step 2 is closing the sidewall vents, and then you basically are blowing out the remaining moisture on the top portion of the bin just with your conventional drying front. And this is our first look at a technology that is exploiting the idea that horizontal flow is or horizontal friction is less than vertical in airflow through grain masses. Here's the Gatco tube with cross flow. This is another premium air delivery system, and again, it is focused on horizontal airflow. This system is focused pretty much exclusively on horizontal. The idea that horizontal friction is lower. You can see that you have extremely good air delivery. By the way it works, as I noted, you're injecting air into these sidewall vents, and then you've got your central vent pipe that provides an easy path out of the bin. So as air is injected into these, it's going to want to flow preferentially horizontal, and because you've got this easy exit, it actually will stick to that horizontal flow path. And the idea again is that you will get less back pressure, and you will get your moisture out of the bin quicker. Very similar technology or very similar theory as the sidewall vents with the rocket. The drying front in this instance would be moving from the sidewalls inwards. So you're moving your drying front, and the moisture is migrating towards that center tube. And again, with this, you wouldn't have as much of a core. So when you move this grain, it would likely move with very uniform moisture. But I'm just speculating that you'd get a nice uniform and blending wouldn't be as critical as when you have a real core at the top of your bin. The last air delivery system is a T-rocket with cross flow, and this is something that we're developing at Wilde Ag Ventures on our family farm. And basically the idea here, as I had noted, we just added a 15-inch or an 18, but we've added 15-inch aeration on top, and you can see here you still have some inefficient air taking a long path coming out the bottom, but the lion's share of the air that's being introduced has a very short path to get out of the bin. The real goal with this design is that we want any air that is injected to have a path out of the bin that is very nearly half the radius. So you can see here, this is a sidewall vent, and basically the air can flow horizontal straight towards us into this sidewall vent and out, and here air can flow up to the other sidewall vent and out. But no matter what path, whether it's from the top of the rocket out, should be roughly half a radius, and this is the type of a design that would ensure a short airflow path. And the idea is to optimize your air delivery and reduce your pressure loss. With this system, the drying front would slowly radially move outward from the core. And again, I like injecting into the core. It just gives you that the confidence that you are getting enough airflow, and the fact that that core is a little bit more dense with the chaff, that you will get good airflow. So that summarizes I guess the real goes into detail with how these different air delivery systems work, and how different designs can enhance your system.